Even the most well-written Java program can generate errors, especially at runtime, when you can't always predict what environment your program is running under. For example, what happens if your program tries to open a file that was inadvertently deleted by another program? Or what happens if you ask a user for a number to divide by and the user types in 0? Dividing by 0 is an illegal math operation. In cases like these, the Java virtual machine will generate or throw an exception and terminate your program. However, you can catch these exceptions and handle the errors yourself, allowing your program to continue running. How is an exception thrown, and how do you catch it? Let's see an example. This code simulates a divide by 0 error. Here's our main number. Here's the number we are dividing by. Here we perform the division and display the results. And this final print statement says we've reached the end of our program. Let's compile this program as is and see what happens. The program throws an exception at the point where we attempt the division and then terminates. We never get to the final print statement. Now let's try and catch the exception. To monitor a code for exception, we put it inside a try block, and then add one or more catch statements for the type of exception we are looking for. Let's explain this section of our code. We're asking the Java virtual machine to monitor this code segment, catch any arithmetic exceptions that might occur, and execute these statements if one does occur. Then fall through and continue to execute the remaining statements in our program. Let's compile this code again. Notice the program didn't terminate prematurely, and we got to the final print statement. Let's try another exception. Here we declare an array with 10 integer elements. And here we try to assign a number to an element that's out of range. Attempting to access an array element outside its range will cause the Java virtual machine to throw an array index out of bounds exception. So we put this code in a try block and catch the exception. Notice you must catch the right exception. You can monitor for multiple types of exceptions in your try block. Just add more catch blocks. But when an exception occurs, only the appropriate catch block is executed. The others are ignored. The execution resumes at the first statement following all your catch blocks. Let's compile this code. You can also add a finally block at the end of your catch blocks. The finally block gets executed after your catch blocks. It's often used for executing additional cleanup code after an exception. Let's compile this code again. Let's follow the path of execution. Here we declare our array of integers with 10 elements. Inside the try block, we attempt to access an element that's out of bounds. An exception is thrown. It's not an arithmetic exception, so we ignore this block. It is an array out of bounds exception, so this catch block is executed. There is a finally block, so the finally block is also executed. And the execution falls through to the last statement. You might ask, why all this trouble with try and catch blocks? Why not just check for errors at the points where they might occur? it's not always practical to check for errors at every point. If you try to write a program that does this, you will quickly notice its disadvantages. You'll be performing error checking after almost every statement. This makes your program hard to read and even harder to maintain. It's a lot easier to just let your code do its thing and check for all possible errors at one common place. Java's exception handling makes this easy.